1.2 graphs of equations in two variables. And also this lesson talks about circles as well. All right, so if we had to graph, again, this equation has 2x and y. It's up to you how you want to do this. You make an XY chart, or a lot of us would just simply solve for y equals mx plus b. And if we made an XY chart, we just randomly choose numbers, and then we're going to plot those points to the graph them. And again, any point that you want on here, so typically we -2, -1, 0, 1, 2, something like that, and just plug those numbers in to get to your values. So I plugged those numbers in, got those values, I plotted those points, and then I connected the dots to make a straight line. And you can check it if you remember y equals mx plus b. This is your m. Your m is 2/1, and this is your y-intercept, your b. And so the y-intercept is right here, and then also the slope is up 2/1, right over run, up 2/1. So that's a good way to check it as well. But the XY chart method always would work. All right, so if we had this right here, again, we're going to make an XY chart, and you just choose random numbers that you want. Again, you can literally choose whatever you want, but if I did the -2, -1, 0, 1, 2 numbers again, and substituted those in, again, I calculated the values, I graphed those points, and it makes a parabola. Remember, anything that's quadratic, x squared is a quadratic, it's a parabola. And of course, it has an axis of symmetry, and it literally parallels, flips over, whatever that axis of symmetry, it flips over because it's symmetrical. So that's how you do that with an XY chart. And here, again, you're just going to make, I have y equals absolute value of x, just make an XY chart and plug in random numbers. Again, it does not make a difference what numbers you choose. Typically, I would recommend you choose some negative numbers, always choose 0, and then choose some positive numbers. Again, it doesn't have to be these 5 numbers, but again, I typically stay close to the origin. So again, if I plug this in, I'm going to get -2, that's going to give me +2, 1, 0, 1, 2. And if I plot these points, 0, 0, 1, 1, 2, 2, and then -1, 1, 2, 2, it actually just keeps going up, but it basically makes a V. Because of the absolute value, it's going to stay, everything's going to stay positive. The Y value is always going to be positive. You'll never have anything down here because Y has to be positive value. Everything in that column is going to be positive to the Y because of the absolute value. All right, so let's talk about x-intercepts and y-intercepts. The x-intercept is where it crosses the x line. So if you look at my graph down here, I just made up some graph, and you notice that as you trace it along, I have a x-intercept is where it hits the x line right there, another x-intercept, and another x-intercept. Those are my x-intercepts. On this particular function, happens to have 3 of them. And notice it has one y-intercept, and that's where it crosses the y line. Now, how do you actually get it? Well, it's obtained, the x-intercepts obtained by setting y equals 0. And I want you to make sense of this. So, like if this point is actually -8, 0. Notice the y is 0. This point is -1, 0. Notice the y is 0. So don't get those. I mean, even if you're like, you can't remember which one do I set equals 0? Think of a point that's an x-intercept, and the y has to be 0. And the same thing for y-intercepts. If this point is 0, -2, notice the x is 0. So to find the y-intercept, you actually put 0 for x. So let's actually calculate some x-intercepts and y-intercepts. So if I was doing this problem and I wanted to find, let's do the x-intercept first, and then we'll find the y-intercept. All right, I mean, you could graph it and find out where it actually, what it looks like, and then see where the x-intercepts are and see where the y-intercepts are. But you don't have to graph this at all. All we're going to do to find the x-intercept, we're going to put y equals 0. And we're going to actually solve it. So this order is 0 equals x squared minus 2, and we're going to solve that. So again, it's a good thing we didn't try to graph it, but if we did, if you plug that into your calculator, the square root of 2 is approximately 1.41. So it would literally be right around here and right around there. Those would be my x-intercepts. So if I had to write the point, the square root of 2, 0, and negative square root of 2, 0, and those are my x-intercepts. All right, so the y-intercept, we're going to put x equals 0, and so literally y equals negative 2. And that's, you just put a 0 right there. And so you get y equals negative 2, and that's the y-intercept. So 0, negative 2 is the y-intercept for that. So if I did graph it, you can see if it rattle it, so it would look like this. All right, so that's finding the x-intercepts and finding the y-intercepts. So let's look at it this way. So if we wanted to find the x-intercepts on this and find the y-intercepts for this, to find the x-intercepts, we're going to set y equals 0. That's going to give us x squared over 9 equals 1. That all goes to 0 if we set y equals 0. And then that's going to give us x squared equals 9 and x equals plus or minus 3. So those are my two intercepts. It has two intercepts. Again, that would be 3, 0 and negative 3, 0. Those are the two intercepts for this. And again, if I wanted to graph it, 3, 0 and negative 3, 0. So to find the y-intercept, I'm going to set x equals 0. So if I set x equals 0, this right here would cross out. And so then you're going to have y squared over 4 equals 1, which is y squared equals 4. So y equals plus or minus 2. So 0, 2, and 0, negative 2. So this is like an ellipse. It's not a circle. It's an ellipse. How to do that. All right. So that's how you find your x-intercepts and y-intercepts. All right, so let's start talking about the equation of a circle. So this you should remember, this is the equation of a circle, and the center of the circle is HK. And so, so x minus h in parentheses squared plus y minus k in parentheses squared equals radius squared. So if I ask you to graph x squared plus y squared, if I ask you to graph this, what you're going to do is notice that in this formula, what is my HK? Well, that literally is x minus 0 plus y minus 0 equals 25. So in this problem, 0, 0, the origin is the center of the circle on this problem. And of course, this is 25, and remember the formula says r squared, so that means the radius is actually 5. So if I ask you to graph that, this is the center, and you go 5 spaces over, you can go 5 spaces over, 5 spaces over, 5 spaces over, that's the radius, and that's going to be a circle. All right, so that's it. How do you graph it? You got to recognize the center. So if I ask another one like this, again, you got to recognize the center. So the center would be 2, negative 1. Again, follow the formula. So that would be 2, negative 1. So if I go to 2, negative 1, and then of course we see the radius of 5 again. So notice, you have to notice the center is the key. And then the radius is 5. So again, the center of the circle, radius is 5 in each of the directions. All right, so let's look at finding the equation of a circle with radius 3 and center 2, negative 5. So what we're going to do, again, you have to remember the basic formula. And so we're going to write the equation with a circle with the radius 3. So if the radius is 3, so this would be 9. And the center, remember this is your h, that's your k. So this would be x minus 2 plus y plus 5. So this is the equation of that circle. All right, so here it says find an equation of a circle. So again, what we're doing is that x minus h squared plus y minus k squared equals r squared. So you don't have to graph this. It doesn't ask us to graph it. But in general, it's a good idea. I think it's a good idea to graph it to give you a general idea what it looks like. And it helps you visualize that what you're finding will make sense. So if I go to 1, 8, and by the way, I want you to notice these are endpoints. So point P is 1, 8. That's point P. And point Q is 5, negative 6. That's point Q. And those are the endpoints of the diameter. So literally what we want to do, if this is the diameter, so we need to find the equation of a circle. So we have to find the center, HK. We have to find the center. So the center is, if you just look, it's right around there somewhere. And what we have to do is find the midpoint between those 2 points, and that will actually be the center of the circle. That's what we want to do, is find the center of the circle, and we're going to find the midpoint, which will help us out. So the first thing, actually, I mean, you should go and find the midpoint. If you remember, the midpoint is basically finding the average of the 2 points. So you're going to take your x values and add them together. So 1 plus 5 divided by 2, and then take your y values and add them together and divide by 2. And so this is the midpoint, which in this case will be the center of the circle. So here we're going to have 3 and then 1. And so if I go to 3, 1, diagram is just off just a little bit. It's actually supposed to be right here. So 3, 1 is the center of the circle. So right now, if we follow this, so 3, 1 is the center of the circle. So right now we have x minus 3 squared plus y minus 1 squared, but we don't know the radius. We don't know this distance of the radius, okay, or this. Either one's actually the radius. So what we want to do is find the distance between, rather, the midpoint. Remember, this is the midpoint, the center of the circle. We want to find that, and P, the distance between here and there, or here and here. It doesn't really make a difference because they're going to be, each one of them is the radius. So it doesn't really make a difference. So what we're going to do is the distance formula between those 2 points, and let's say P, and the midpoint, or let's just call it C for center. So we're going to find that. So that's the distance. Remember that formula. So I went ahead and did the work of using the distance between, again, point P and the center, and I got the square root of 53. So the distance is square root of 53. So when I actually square that, remember, radius squared, I'm actually going to get 53. So this is the equation of the circle. That goes through that. And again, that the circle would look like this. All right, so let's look at this equation. If I have this equation, notice it's x squared plus y squared plus 2x minus 6y plus 7 equals 0. And I want to find, show that that is a circle and find the center and the radius. Well, what we're going to do is do completing the square. First step is group the x's together, and then group the y's together. So we're going to do completing the square. Completing the square, this right here to add 1, add 9. I'm going to add 1 and add 9 to both sides. That's a perfect. That's why it's called completing the square. And then you can see the center is negative 1, 3, with the radius of 3. Square root of 3. All right, and lastly, what we have is types of symmetry. If it's reflective about the x-axis, y-axis, and the origin.